Welcome to Part 2 of Using Response Surfaces in DesignXplorer. Part 1 demonstrated how to set up and generate a response surface. This video will continue with the same project, now focusing on how to interpret some of our response surface results. First, I'll look very briefly at the min-max search. When I select the min-max search, you can see that the table view shows the calculated minimum and maximum values for each output. Next, I'd like to check my goodness of fit metric. The response surface is interpolated from design points in the DOE. The goodness of fit metric is calculated for DOE points and can also be calculated for verification points to check how accurately the response surface can predict the design points. The predicted versus observed chart shows goodness of fit data for one or more outputs. Here, both of my outputs are shown. I can display or hide them as needed. Design points are represented by squares, and verification points by circles. When I hide the design points on the chart, you can see that 3 verification points, the number I requested, have been generated for each output. When I hover over a point, its input and output values are shown in the Properties view. For the outputs, both the predicted and observed values are shown. Here, you can see that most of the points fall on or near the line, which means that the response surface was able to predict values for most of the design points within its range, including the verification points. From this, you can tell that the response surface is a pretty good fit for the DOE points. Goodness of fit data is also shown in the table view. Each of these criteria is calculated with regard to the 2 outputs. The stars show how closely the parameter comes to the ideal value for each criterion. 3 stars are the best match, and 3 red crosses are the worst. Since my response surface has been generated by the standard response surface second-order polynomial algorithm, the Advanced Goodness of Fit report is also available. In the table view, right-click an output and select this option. This report shows more detailed goodness of fit data, such as the coefficients for each term of the regression model, and a comparison of sample and approximated output values. Next, I'll take a closer look at the response chart. On the 2D version, I can pick an input and an output. I want to look at my safety factor, so I'll set the y-axis to safety factor minimum. The x-axis is set to an input parameter. Here are the curves for thickness and for depth. These are both positive curves. For lower radius, a negative curve. And for angle, a flat or neutral curve. When I adjust an input by moving these sliders, it changes the definition of the response point. This change is shown in the chart, the table, and the output parameter values just below the sliders. Note that when I increase the depth, the safety factor goes up, and when I decrease it, the safety factor goes down, a positive correlation. But when I increase and decrease the lower radius, it has the opposite effect on the safety factor, a negative correlation. The same thing is shown on the 3D chart. I can select input parameters for the x and y axes and an output parameter for the z-axis. Here, the response surface shows the response of safety factor minimum to variations in angle and depth. I can change the parameters, and I can show design points if I wish. Again, I can move the sliders to visually explore the impact of the 2 inputs. Finally, the 2D slices chart combines the benefits of both the 2D and 3D chart formats. It compresses the data of the 3D chart and presents it in a 2-dimensional format. Controls for this version of the chart vary slightly according to the types of input parameters. In this example, all of my inputs are continuous parameters, so I can specify the number of slices shown on the chart. However, if I had one or more inputs that were discrete parameters or continuous parameters with manufacturable values, the number of slices would be determined by the number of levels defined for those input parameters. This video has demonstrated how to interpret the min-max search, goodness of fit, and response chart results. This concludes Part 2 of this series. Join me for Part 3, which will focus on interpreting response chart sensitivity results.